Okay, so this is the starting of the note. You can see the topic here, electrochemistry. So first we talk about electrolysis. Electrolysis is a way to decompose compounds. So decompose compounds means break down the compound. So for example, how you decompose a compound. So let's say I have NaCl. You decompose it. That means you separate the Na and the Cl. So at the end you get Na and Cl. For example, something like this. Okay, so you are able to break down. They are originally a compound. You break down and they are separated as element. So how to do this? Use electricity. Okay, so use electricity, and we call this process electrolysis. So the second point, we have the reductions. Reductions of positive cation happens at the cathode. So positive cation, who is the positive cation? Is Na. So we have to know that this Na is actually Na positive ions. It's an ionic compound. This is Cl negative. So because of that, the positive cation is the is going to the cathode. Cathode is a negative terminal, as you can see here. Cathode is negative terminal. The positive cations will go to the negative terminal. You know, opposite charges attract each other, so that's why something like that can happen. And then it is reduced. It is reduced. What is meant by reduce? Reduce means they accept electrons. So Na positive accept electrons and then become Na. So this is reductions. Okay, reduction happens on sodium ions and then it becomes sodium solid. Okay, so oxidation of negative anions happens at the anode. So negative anions is the Cl minus. So Cl minus will go to the anode. So Cl minus is the anions. Anion is negative ions. They will go to anode. Anode is the positive electrons. So you know, negative go to positive. They are attracting each other. Okay, so they attract and hence the anion come here, and then the electron is donated. Electron is donated. So the negative charge is given away. So it becomes chlorine. The electrons are given away. So we have two chloride to form Cl2 and 2 electrons. So this is called oxidation. Oxidation is to donate electrons. Okay, so and that happens at the anode. So they give example. So at the anode, the chloride become chlorine and 2 electrons. So this is same with my example. At the cathode, they are using 2H plus. 2H plus 2 electrons become H2. Become hydrogen gas. For me, I'm using Na plus, take electrons and become Na, get the sodium. It depends. Depends on how you do it. Now we look at the next one. Decomposition of an electrolyte. With the help of electric current. Okay, so what is electrolyte? So electrolyte is the NaCl for my case. NaCl in molten. NaCl in molten. Molten means you make it melt. You melt the NaCl, and then that is electrolyte. Okay, electrolyte. So the electrolyte can be in molten form or in aqueous form. Aqueous. Molten or aqueous. Okay, so let's see the information here. electrolyte, aqueous solution of ionic substance. So you can put NaCl in water, then you get NaCl in aqueous, that is electrolyte. Or you can also put the NaCl in a crucible and you heat it up until it melts. That is molten form. Molten form is without water. Aqueous form is with water. So they are, no matter it is aqueous form or molten form, the main characteristic is once it is in aqueous form or molten form, the Na plus and the Cl minus, I mean in general, right, the positive ion and the negative ion are free to move around. It becomes free. It's not like in solid, they are held together by ionic bonds. But when they are in molten or aqueous, the ions are free to move. That's why they can move to the different electrode because they are free to move. So they can conduct electricity. Electricity can just flow around the molten or the aqueous electrolytes because the ions are free to move. They are not hold by the ionic bonds anymore. So they become mobile ions. So the mobile ion means the Na plus and the Cl minus. They are free to move and hence conduct electricity. Okay, then we see the next point, electrodes. So you can see the setup of the electrolytic cell is like this. We put the electrolyte here. Okay, the electrolyte, and then the electrolytes have free mobile ions that are free to move. So they will just move in this particular way, where the negative ion will stick to the anode, the positive ion, the cation will stick to cathode. So it's kind of easy to remember: anion, anode, cation, cathode. So it sounds the same, right? Anion, anode. The front part sounds the same. Cation, cathode.
So, sir, cathode is the negative electrode. So, the positive charge is the cation.
Yes, cation. This is cation.
Okay.
So this is the other way around. Negative charge is the anion. Anion sticks to the anode. So something like that. And for this cell, right, normally they will put it like this. They'll put like this. Okay, to represent the cell. So if you see there are longer line that connect with the electrode, so this is positive electrode. Positive electrode is anode. So anode. So if they are using the shorter line to connect to the electrode, shorter line means negative. So this is negative electrode. Negative electrode is cathode. And then we have the beaker. If you are using aqueous, we put beaker. But if you are using molten, right, so we have to put it in crucible. Okay, let's say I draw crucible since beaker has been drawn there. So I use crucible. Crucible is for molten. Molten. Okay, it's hot. You need to heat until it melts. So maybe a few hundreds or a few thousand degrees Celsius. So it is hot. And because of that, we cannot use the glass container anymore. We have to use the crucible containers. So now, let's see. The positive, and then here the anion will come here. The cation will come here. Okay. So now let's continue with the information. Electrodes, rods, which help current enter the electrolyte. So the current is moving in the external circuit as well as through the electrolyte. Okay, so inert electrodes do not take part in the reaction. So an example of inert electrode is like graphite or carbon electrode or graphite electrode, or even the more expensive one like platinum. So they are inert electrodes that do not take part in the reaction. That means if you are using graphite, so at the end the graphite it just remain there, not reacted or not dissolved in water. Okay, so it just remain as graphite all the time. Okay, so reactive electrodes takes part in the reactions. If they take part in the reaction, normally you should expect something like this, where the anode will become thinner because they take part in the electron. So some of the substance in the anode has been used up, and then it becomes thinner. Whereas the cathode will become thicker. The cathode will become thicker. So how to remember the anodes to be thinner and the cathodes to be thicker? So of course there are plenty of ways. So one of the way is you just imagine the pictures. So anode, let's think of N. It sounds more or less the same. N. So N is thin. You see, I draw a very thin end. Okay, cathode, thicker. Cathode, think of cat. So the cat is fat. Okay, so it will help you to remember through diagram. So the cat is fat. Okay, so it will help you to remember anode to be thinner, cathode to be thicker. Okay, so it takes part in reactions. So example is you use copper electrodes for both cathode and anode. You use copper together with copper 2 sulfate as the electrolyte. So where you can see the common metal here, okay, copper and copper ions. So if they are common, then they will become the copper electrode will become active electrode or reactive electrode. Must be the same metal together with the metal ions. If they are same, then it become active. So we take it in that way. Okay. Now let's see the arrow in the pictures here. So this arrow is basically the flowing of the electrons. Flowing of the electron is from anode to cathode. So at the same time, you also need to know more information about anode. Okay, so I put together. You see, first, let's say anode oxidation happen. So anode, what happened in anode? Oxidation. What is oxidation in a more sensible way? So you see here, oxidation means donate electrons. Oxidation is what? Oxidation is donate electrons. Donate electron. Okay, so that is what happens to anode. Donate electrons. So that's why electrons from anode come out to the external circuit. That means electrons are donated. Who supply the electron? The anion. The anion supply the electron. Okay, from anion. From anion. So the anion supply the electrons. So electron flow and come here. Okay, so after that, when the electron reach here, who is going to take the electrons? The electron is accepted by the cation. So that's how you can see the cation accept the electrons and become sodium. So that's happened to cathode. So okay, I leave a bit more space for anode, so that I can put more. Okay, now we see cathode. Huh? So first we say reduction happens at cathode reduction, as you can see here. Cathode reduction. Reduction. So what is mean by reduction? Reduction means accept electrons. So reduction means accept electrons. Accept electron from where? From anode. The electron come from anode. The accept electron. Accept electron, and the electron is given to the cation. Okay, given to cation. That the electron accept the electron, and then the electron is taken by the cations. Okay, so the third thing is we have to know that anode is positive in electrolytic cell. Electrolytic cell. Number 3, cathode is negative in electrolytic cell. So far I just put 3. I gather up actually. I gather up the information for anode, and I gather up the information for cathode. I put together so that you can see it clearly. Okay, so now let's see the principles in the flow chart here. Okay, we have.
So,
Yes.
what does it mean when you say negative means? Cathode means it's negative electrolytic in electrolytic cell. Is it that it is a negative electrode?
Yes, it's a negative electron. You see, cathode is negative. Cathode is negative electron. It's negative electron. So why I had to say it in this way? Negative cathode is negative in electrolytic cell. Basically because cathode can be positive in voltaic cell, so it can be positive. So I need to make it clear. Okay, make it clear. Positive in voltaic cell, that will come later. So since you said about that, I just write it down in blue color first. Cathode is positive in voltaic cell. We will learn voltaic cell later. And cathode is negative. Anode is negative in voltaic cell. Okay, so voltaic cell will come later. Let's see first. These are all the electrolysis. Let's see where's the voltaic. Voltaic cell is not in the syllabus. Okay, so voltaic cell is, since it's not in the syllabus, then it's okay lah. Voltaic cell is just where they put voltmeter here. They put voltmeter here, then it becomes voltaic cell. Okay, but it's not in the syllabus, so
if it's not in the syllabus, then it won't come out for the exam. So
yes, it won't come out in the exam.
Will come out?
Will not come out.
Oh, okay.
So we are not going to care about that. So just need to remember the one in red color. Okay, now let's see. We look at the principle here. So we have 2 types of electrodes: molten electrode. 2 types of electrolyte. Electrolyte. The first type of electrolyte is molten electrolyte. That means it's melted you heat the ionic compound until it melts. Okay, so for example, you can see something like NaCl liquid, and then it's molten form. Aqueous, that we put NaCl AQ. So from the physical state symbol here, you can differentiate it. Molten is liquid, and then aqueous electrolyte is AQ. Okay, if you are using molten, so you should expect crucible to be used. Crucible to be used. Okay, so after that, at the cathode, you will see metal. Okay, let's take a quick look again. At the metal, you will see metal. At the cathode, you will see metal. So let's recall back. At the cathode, you have the positive ion, positively charged ion. Positively charged ion in my example is Na plus. Na plus, what happened to Na plus? Na plus go through reduction, accept electrons. Na plus accept electrons and become Na. So that's how you get the Na metal. Okay, it's a metal. You will get metal as your product. Okay, so at the anode, you will get non-metal as the product. Okay, let's see. We take a quick look again at the anode. Anode is a positive electrode. Positive electrode attract the negative ion. Our example, negative ion is chloride. Okay, chloride. Chloride which goes to the anode. What happened? Oxidation happened. Donating of electrons happens. And chloride donate electrons and it becomes chlorine. It becomes chlorine. Chlorine is non-metal. So that's why non-metal is written here. So you have to give yourself an example so that you can accept this. So if I'm using NaCl liquid, then my metal is Na. Na metal. Okay, my non-metal is chlorine. Chlorine is gas. Okay, so we settle for molten already. Molten is kind of simple. Let's say, for example, I put another example again. If you are using, let's say, PbBr2 liquid, that means molten form. You put it in your crucible. Then what happens is the Pb is Pb2 plus. In molten form, it becomes mobile ions. Bromide is Br minus 2 of the bromide. Okay, so no matter what's the quantity, the thing is the positive ions. The positive ion is the cation. Will go to the cathode. Pb2 plus will come here. Stick to the negative electrodes. The bromide will come here and stick to the anode. So what happened? It become from ions, it become element. We call this process discharge. Discharge means lose their charge. Okay, so how they lose their charge? It depends. If positive ions, they have to accept electrons to discharge. Okay, to put negative to it to neutralize with the positive here. So try to imagine in that way. So Pb2 plus need to take electrons to become Pb. So this is the metal. This happened at the cathode. This happened at cathode. Happen at cathode. And this is called reduction. Reduction means accept electrons. Okay. Whereas bromide go to the anode. Bromide go to the anode and remove the charge. How it remove the charge? By donating the negative charge as electrons. So it becomes bromine plus 2 electrons and balance the equation 2. So this happened at anode. Anode, what happened here? Oxidation. Oxidation. So oxidation is donating electrons. So that's why the electron is produced at the end. So very easy, right? Very easy to determine the product. Very easy to determine the product. But when it comes to aqueous electrolyte, the situation is getting more complicated because of the presence of water. The aqueous means water. Water is also there. So what happens to water? Water forms positive ions and negative ion as well. Water form H plus and OH minus. They form ions also. Okay, so because of that, let's say for example, if you have NaCl aqueous, which ions go to the cathode? Try to recall back. Cathode, positive ion go to cathode. So positive ion is Na plus. But it's not just Na plus, The water has H plus that go to the cathode as well. So H plus also. H plus. So we have Na plus, H plus. We have two choices here. And you can only choose one of these to form the product. And how to choose? Of course, you have to look at the reactivity series. So we have to compare the electrochemical series. Electrochemical series. So we have to look at the electrochemical series. Let's take a quick look. We look at the website to find out the electrochemical series. Okay, so let's see. Electrochemical series. Let's see the image. Okay, so I want to make sure we are using the IGCSE chemistry. Okay, let us put the Cambridge also because IGCSE itself has a few exam board who do this. Cambridge IGCSE chemistry electrochemical series. CIE IGCSE. Okay, this should be good to use. Okay, now let's see. Okay, this is the one, the Electrochemical Series actually. Okay, so we have the arrangements of the elements here from the most reactive to the least reactive. Okay, so potassium, sodium, lithium, calcium, magnesium, aluminium, carbon, zinc, iron, hydrogen, copper, silver, gold. Okay, so this is the members. Okay, so you have to remember this, and after that, what to do is you have to know whoever that is less reactive, it will be chosen to form element. It will be chosen to form product. Okay, so you have to remember this. Of course, our concern is how to remember this. How to remember. There are so many elements here. Of course, these elements are just for the positive ion. Negative ion has another series. So let's see whether it's given or not. Negative ions. Okay, I just take a quick look. I think it's not given here.
Sir.
Yes.
So the most reactive elements, the most reactive positive charge will be reduced in the cathode.
Most reactive will not be reduced. It's the least reactive. The least reactive will be reduced.
Okay.
Yeah. Let's say example, you see how we apply our idea here. Okay. Let's say you have Na plus and H plus. Okay, we look back at our Na plus, sodium, H plus, hydrogen. So whoever that stay at the bottom are less reactive. So hydrogen is less reactive compared to sodium. So that's why hydrogen will form product. Hydrogen is reduced. Hydrogen is reduced. Okay, so
Sir.
okay, so that's the thing. Na plus, H plus. At the end, we choose H plus. Why we choose H plus? Because H plus is less reactive. Less reactive, less reactive, then it is reduced. It is reduced, Okay. Now, how the note said it? You see, they said it in a slightly different way, but the concept is just the same, Aqueous, we always have a metal ion together with H plus. The metal ions can be more reactive than H plus or can be less reactive than H plus. More reactive means they stay at a higher position in the electrochemical series. Low reactive means it stay in a lower position compared to H plus. So if they stay at a higher position, then they are not going to form the product, but H plus is going to form the product. So for example, right, let's look back at the series over here. So you look at this series, whoever that are above of hydrogen ions, plenty of them. Okay, so if they are above of hydrogen ions, they are not going to be chosen to form product. They will remain as positive ions. And because of that, hydrogen ions will be chosen to form the product. Hydrogen ion is less reactive compared to all this. So hydrogen ion will be chosen to form product, and hence H2 is formed. Okay, H2 is formed. So that's why H2 is formed. Okay, but if the metal ions is lower in reactivity than H plus, that means if the metal ions are copper, silver, and gold, then these metal ions will be chosen to form products, to form copper or silver or gold. And because of that, the note put the metal form over here. Okay, metal form. Okay, so let me pull it for you. Based on that information, I can say that there will hydrogen is formed if the metal ions are K plus, Na plus, Li plus, Ca2 plus, Mg2 plus, Al3 plus, carbon I just ignore lah. It's not metal. Zinc 2 plus, and Fe2 plus. So if the metal that you use are all these, then this metal ion will not be chosen, but H2 is chosen. I mean H plus is chosen to form H2. Okay. So in what situation metals form? If the this one point an arrow here. Okay, metals form if the ions are these three. If the metal ion are, so if the metal ions are Cu2 plus, Ag plus, and Au plus, and then they will form metal. Okay, so basically we can just remember it in that way. Okay, so let's see another thing. Electrochemical series. Remember trick. Okay, let's see the image. Okay, so from here, this is one way. Please send lion, cat, monkeys, and zebra into lovely hot country. Sign general penguins. One way, so there are more than one way. Okay, more than one way. So you can just check on your own. Okay, so like stop calling me and so on. Okay, so it's up to you. Yeah, so you just put effort on this. You can always Google search to find out the way to remember it. Okay, now let's continue. Okay, now let's see the second part. The second part is the anode there. So for the anode, the N ion will stick to the anode. So the N ion here is the negative ions. So it will be the Cl negative together with the negative ion from water, which is OH negative. OH negative. And of course, who is going to be selected to form the product? That is also a series. Okay, so a series to remember it. Now let's take a quick look. What series are we going to use? Okay, so we look at the website again. Okay, so Cambridge IGCSE Chemistry Electrochemical Series of anions. Okay, let's see the image. Okay, this should be good enough. So you can see here, fluoride, sulfate, nitrate, chloride, bromide, iodide, hydroxide. So these are the series. Okay, so whoever that stay at the bottom is less reactive and it is easier to discharge. Whoever that stay on top is more reactive and it is hard to discharge. Okay, so you have to know this, and then we have to choose the one that stay at the bottom and form product. And from here, you will see something like this. Seems like the OH minus from water stay at the bottom, and it seems like we are going to always choose the OH minus to form product. But that is not the only situation. There are exceptions to this. Okay, exception. So let's see. What else are we going to see? Yeah, let's come back to the notes again. Okay, so when you look at the notes again, what can we see is halide present, halide not present. Why we want to care about halide? So let's see the series again. The series will help us to remember it. Chloride, sulfate, nitrate, chloride, bromide, iodide, and hydroxide. Okay, so they put it in this way. I draw a line here. Okay, I draw a line here. And you ignore the fluoride. Then these notes will make sense. Okay, so halides are group 17. So they are fluoride, chloride, bromide, and iodide. But you don't look at fluoride. Don't look at fluoride. So fluoride is too reactive. No need to care about that. So no need to care about fluoride. Just look at chloride, bromide, and iodide only. Then the notes will make sense. Halide presence. If halide presence and it is concentrated, then halogens form. Okay, what is meant by halide present? If halide present, that means these are the halides. If chloride, bromide, iodides are there, actually fluoride is also halide, but don't care about fluoride. So our discussion exclude fluoride. So if chloride, bromide, and iodide are there and it is concentrated, then you have to choose the halide to form halogen. Halide to form halogen means what? That means chloride to form chlorine, bromide to form bromine, iodide to form iodine. So they will form products if it's concentrated. Okay, so but if it's dilute, then you don't choose the halide, but you choose the hydroxide. You choose the hydroxide to form product. Hydroxide who form products will form oxygen as one of the products. So the equation is something like this. Hydroxide form H2O plus O2 plus electron. Okay, so balance the equation. So hydroxide will form water. You can't see water easily because it's in aqueous, right? So and oxygen. So oxygen is formed. Okay, so that's the thing. Now let's say, for example, you have chloride and hydroxide. Chloride and hydroxide. So if chloride and hydroxide are there, it depends on whether the NaCl is dilute NaCl or concentrated NaCl. So if it is dilute, then you use this way. So oxygen is formed. But if the NaCl is concentrated NaCl aqueous solution, then chlorine is formed. So it depends on whether it's concentrated or dilute. So, okay. But if halide is not present, that means these three are not present, but it's something else, like sulfate, nitrate, or this one, fluoride. Okay, so in that case, they are too reactive. They are too reactive compared with hydroxide. Although it is concentrated, it is still not going to form products. Okay, so if they are not the halide, they are others, so they won't form product at all, basically because they are too reactive. So who is going to form product? The hydroxide will form products. Hydroxide form products, and the products form are hydroxide forms oxygen. The product forms is oxygen gas. So that's why. Okay. Halide presence, I put a short notes here. Halide present means you have Cl minus or Br minus or I minus. Then it depends on concentrated or solid or dilute. If concentrated, then the chloride, bromide, iodide will form chlorine, bromine, and iodine. If it is dilute, then what happens? The hydroxide will change to oxygen as one of the products. If halide is not present, then hydroxide will change to oxygen. So that is the explanation so far. Okay, now let's see more example. Based on this chart, we can remember something like this. Okay, so the products form. So these are important. They asked in exam questions. Okay, now let's see more example. Molten lead to bromide. You know, it's molten, very simple. The lead will form product. Lead 2 ion form lead, becomes lead. Bromide ion become bromine. Okay, so very simple. No need to care about the H plus and the OH minus. Concentrated hydrochloric acid. So concentrated hydrochloric acid, the positive ions are the hydrogen ions from hydrochloric acid as well as water. It's just one kind of positive ion, which is H plus. So H plus form hydrogen gas. But for the negative ion, we have chloride as well as hydroxide. Hydroxide from water is also there. So we have chloride and hydroxide, and this is concentrated. Then chlorine will form product. So that's why chlorine. Concentrated aqueous sodium chloride. Okay, now whoever that stay at the lower part, they will form products. So we have hydrogen and sodium. Hydrogen stay at the lower part. You know, hydrogen is below of all these. So sodium is here. So if the metals have sodium, sodium is not going to form product. Hydrogen will form the products. So that's why hydrogen. Okay. The negative ions, we have chloride ions as well as hydroxide ion. Chloride, hydroxide, it is concentrated. You see the concentrated words is there, and then they will form chlorine. They will form chlorine as the products. Okay.
So,
Yes.
for example, the concentrated hydrochloric acid, right? The hydrogen that it reduced in the cathode,
Yeah.
the one is from the hydrogen. The one is from the hydrochloric itself, right? And it's not from addition of water and all that thing, right?
It's just fine actually. The H plus can be the H plus from HCl or the H plus from H2O. It's just fine.
Oh, but if let's say we use a concentrated liquid, so is that going to be like water in the concentrated substance?
Yes. Concentrated here is the concentrated aqueous It's not the molten, molten no water one. No water, no need to care about concentrated or dilute,
So concentrated hydrochloric acid also has water,
Yeah, also has water.
which means its element is H plus, Cl minus, and also H2O.
Yes, true. You have this HCl and H2O in the electrolyte.
Okay, sir.
Yeah. Okay.
What about the concentrated aqueous sodium chloride? It has sodium chloride and also H2O.
Yes, correct.
Okay, sir.
Sodium chloride, H2O. Yes.
Can understand.
Yeah. So that's why it is good to write it down. So let's see the example here. Okay, let's see. Electrolysis of dilute sodium chloride solution using graphite electrodes. The ions present, Na plus, Cl minus, OH minus, H plus. So NaCl is from here. H plus and OH minus is from water. So who is going to the anode? The anion. The anions are negative ion. So Cl minus, OH minus. The cation will go to the cathode. The cations are the positive ion. So we have Na plus and H plus. So this is a step-by-step method, So we think of how they are separated by the anode and the cathode. And then we choose the products. We choose the product. So this is dilute. Dilute means they are not going to form halogens, so they are going to form oxygen. So the product form is the oxygen gas. So observation, colorless gas. Colorless gas. So if you want to put more details, you can even put colorless gas which light up a growing wooden splinter. So you can put more details if you want for the observation, or else just put colorless gas. Oxygen gas is colorless gas. Okay, so but there are more than one kind of colorless gas, So to make it clearer, you say the colorless gas which light up a growing wooden splinter. So that makes burning happens. So for the cathode, who form the products? So remember, if they are not copper, silver, and gold, so they are not going to form products. So H plus will form products. H plus. It's kind of easy to remember. So only copper, silver, and gold can make the metals form. And these three are the three metals that are commonly used in sport games. When you win, then you get medal, right? The medal are gold medal, silver medal, and the bronze medal. So it's these three things, So it's the gold, silver, and the bronze. So it's gold, silver, and copper. So if it's not that three, then H2 is formed. So we can remember it in that way. So now, so it's not that three. So you don't take sodium. You take H plus to form product, hydrogen gas. Hydrogen gas. Okay. So after that, what's the observation? Observation, you just write hydrogen gas, right? It is also a colorless gas. Colorless gas. So the thing is, if both are colorless gas, then we know how we know which is which, you know. So this colorless gas has its own properties also. So which produce pop sound with burning wooden splinter. So if you want to put more details, you put this. Produce pop sound with burning wooden splinter. Okay, so explanation. So this explanation, I just say that only, how to explain. Okay, so you can just say hydroxide is less reactive than chloride. Hydroxide is less reactive than chloride. So hydroxide is chosen to oxidize to form oxygen gas. So I write in short, hydroxide is less reactive. Okay, now explanation. Why you choose H plus? Okay, so in details we can say hydroxide is staying in the lower position of the electrochemical series. It is less reactive, so it is chosen to form product. H plus is reduced. So that is the more details. In short, H plus is less reactive. Okay, so half equations. Hydroxide form oxygen, form H2O, form electron. Balance the equation. So this is the equation. This one, H plus, accept electrons. Then I form hydrogen gas, H2. Balance the equation. So settle for this. Now we look at the next one. Electrolysis of, yes.
Can you show me the last one? I still haven't finished.
Oh, okay. Yeah, sure.
Can you please give me a few minutes to copy, sir?
Oh, why not you just screenshot and
Oh, okay. Yeah. Okay.
I'll write everything
Then
quickly.
we can go to the next one.
Yeah. Okay. Have you done?
It's okay. I can look at the recordings again later and do.
Okay, yeah, sure. Okay. You know, these chapters is a long chapters. If
Yeah.
not, if it's a lot of to handle. Yeah. Now, electrolysis of concentrated sodium chloride solutions using graphite electrodes. Now it's concentrated. Okay, again, the ions attracted to the anode, there are anions. So anion are chloride and hydroxide. So cation is
Sodium and hydrogen.
okay. So if it's concentrated and halide is there, we have to choose halide.
Halide.
So chlorine gas. Chlorine gas. Okay. So observation, you have to know this is a greenish or yellowish gas. So let's say I just write yellowish gas. It's around green to yellow. So the chlorine gas. And we have sodium and H plus. So who is going to form product? Of course, it is H plus. It's H plus. So hydrogen gas. So gas is colorless gas. So if you want to put more details, just go ahead. Which produce pop sound with burning wooden splinter. Okay. Explanations, same. Why chlorine? Chlorine is chosen because they are using concentrated sodium chloride. So when they are using concentrated sodium chloride, we have to use the halides to form the products. So yeah, why hydrogen is chosen? Because hydrogen is active compared to half equation. Correct.
Sir, have you written the explanation part for this example?
So
Hello, sir.
yeah, I'm writing.
Okay, but I can't seem to see it.
Oh,
I think
so you can't see the.
with the network.
Oh, let me see. They are light.
Because
rotating
it's
here.
so.
Okay, let me see first.
Okay.
Let me check the internet. Hello.
Now I can see, sir. You have done concentration for the anode part.
Okay. So let's continue. Concentrations. Is the factor that determine the formation of products.
Sir, I cannot. I can only see the word concentration and not the rest.
Oh.
Okay, now
Let me
can.
see.
Yeah, now can see.
Oh, so it takes time to load. Okay. So concentration is the factor that determines the formations of products. So if you have concentrated chloride, then chloride is formed. Okay. Whereas for the other side, the hydrogen gas is formed. Why? Because hydrogen is less reactive. Hydrogen is less reactive compared to sodium. Okay, now let's see the next one. Example again. Electrolysis of concentrated copper 2 sulfate solution using graphite electron. So we have copper, sulfate, hydroxide, hydrogens. So the anodes will attract the anions. Yeah.
So for the electrolysis of concentrated sodium chloride, right? You have also written the explanation for the cathode part, right?
You mean?
The hydrogen gas.
Yeah. Hydrogen is less reactive.
So you have written the explanation.
Yes.
Sir, I think there's something wrong with the network. I can't seem to see the explanation for the hydrogen gas. Oh, okay.
So the writing is not coming up.
And also the half equation.
Oh, half equation I haven't yet. I forgot to write. So,
But the half equation
H
is
plus.
2H plus 2E negative to hydrogen, right?
Yeah, hydrogen. So can you see it now?
It's just H plus electron there.
Oh, you can't see the H2 yet.
Yeah.
Maybe I have to wait for a while. How is it now? Are you able to see it now?
No, sir, but I think it's okay. You can just go to the next one. But I couldn't see the next example actually.
So I scroll to the next example already. Can you see that?
No.
No, huh?
Oh,
Okay.
now
So
can.
something wrong
Now
already. Can, huh?
can. Now
Okay.
can. Yeah.
So I mean the internet is slower. Slower than expected, huh? Okay. Slower than my voice, at least. So okay, let's continue.
Okay.
Because I'm changing the internet, so maybe you need time to make it smooth. Okay, so sulfate, SO4 2 minus, and then hydroxide. You know, just now I draw a line saying that if they are not halide, no chance to be selected. Okay, if they are not halide, if they are not chloride, bromide, and iodide, there is no chance to form product at all, no matter how concentrated you use. So because of that, sulfate has no chance to form products, even though it's concentrated. So hydroxide will form products. Okay, so product form oxygen gas. Observation, colorless gas. If you want more details, you can just say wish same like just now, light up the glowing wooden splinter. So you can say that again. Light up the glowing wooden splinter. Okay. So now let's see the cathode part. We have cations, which are Cu2 plus and H plus. So you think of the sports game, you may get gold, silver, or bronze. So copper is under the bronze, so they will form products. So if there are the three of that, they will form products. So products, copper, metal, copper metal. Observation, what we expect, gold, silver, bronze. So the color of bronze you should know, right, is like brown color. So it's a brown solid. Brown solid, huh? Okay, so explanations for this, you just say hydroxide is less reactive. This one, Cu2 plus is less reactive. Okay, half equations, OH minus, H2O, O2, electron. So 4 hydroxides, 2 water, 4 electrons. Cu2 plus accept electrons, become Cu. Okay, now let's see more example. Electrolysis of copper 2 sulfate solution using copper electrodes. Now they use copper electrodes. The copper matches with the electrolytes, the copper 2 ions. So in that situation, it becomes active electrodes. So when it's active electrodes, if you still remember the explanation just now, the anode, think of end, it becomes thinner. The cathode, think of cat, it becomes thicker. And what happens actually is something like this. We put everything in details here. So we have ions that are attracted to the anode. There are the anions, sulfate and hydroxide. None of these is chosen to form the product. So what happened is not these two that are chosen to form product, but it is the anode that becomes thinner. Anode. Okay, so right in details. Anode becomes thinner. Okay, so the product is actually the copper, the copper electron. Copper electrodes. Okay, I just write the product straight away. I put the copper electrode kind of thing in the explanation. So the product is Cu2 plus. So explanation, copper electrode dissolve to form copper 2 ion. Okay, so half equation, Cu solid from the electron becomes Cu2 plus in aqueous plus 2 electron. Physical state is not required. I just show it here to let you see it clearly. Okay, now that is how the active electrodes makes the things work. It will make the anode become thinner because the copper from the anode dissolve in water to form copper 2 ion. So that's why it becomes thinner. Okay, so for the cathode side, the cat ions, Cu2 plus.
So this is done using a voltaic cell.
It's still electrolytic cell.
Oh, okay.
Voltaic cell is not in the syllabus. So
Okay.
Electrolytic cell, but it is where you don't use graphite electron, we use copper electron.
Okay, sir. And it has dry cells, right?
Yeah, it has dry cell.
Okay.
Yeah, dry cell is on top of the electrolytic cell. Yeah. Okay, so Cu2 plus and H plus. So what happened? Cathodes becomes thicker. Cathode becomes thicker. So product form is Cu. Okay, so what happened is the copper 2 ions is reduced to form copper metal which deposits on the cathode. Okay, so the equation is the Cu2 plus get electrons and become Cu. So just the other way around compared to this. So that is how the electrodes become active and something like this happens. Okay, so it's just copper that play the role on both sides. Okay, so Okay, now let's see this. Electrolysis of silver nitrate solution using silver electrons. Using silver electron. Okay. So again, there is a common. The metal and the ions are same. So it becomes active electrodes again. So active electrodes, remember, this is active electrons. Or the reactive electrode. Okay, so the ion attracted, of course, is the anion, NO3 minus and OH minus. None of these is chosen to form products, but the products form is, remember, anode become thinner basically because it dissolves in water. The anode dissolves in water. So the anode is the silver anode. The silver dissolves in water to form silver plus. Okay, so observation is anode becomes thinner. Okay, so the explanation will be just the same here. Anode electrode dissolve to form, silver electrode dissolve to form silver 1 ion. Okay, so this explanation. Okay, so silver electrode dissolve to form silver 1 ions. Okay, so now let's continue. The half equation. Silver change to silver plus electron. Okay, so on the cathode side, we have cation ions, which are Ag plus and H plus. So observation is cathode becomes thicker. Product form is Ag. Explanation, same as here. Silver 1 ion is reduced to form silver metal, which deposit on the cathode. So silver 1 ion are reduced to form silver metal, which deposits on the silver electrode. Okay, now let's see the half equation. The silver ions accept electrons and become silver. Okay, so we have done the first part. Okay, we have done the first part. So the second part is about the application. So we look at application after a while. So let's go through some questions first so that we get used to how to answer the exam question. So let's take a look.
So,
yeah.
Actually, I can't see your last, the last example.
Oh, you mean this one?
The one with the silver electron. Yeah.
Silver, oh, you can.
Yeah, I didn't see.
Oh. So how is it now?
Yeah,
that's
okay.
that page.
So, now I can see.
Oh, so it means from your side the screen is a bit slow compared to my voice.
Yes.
Oh, okay. So the internet slowed down a little bit already, after I changed the internet. Okay.